Thanks. I will get right into it. So JS engines, hopefully most people know what they are, but basically everyone knows what V8 is. It's what Chrome uses, what Node uses, what Dino uses. JavaScript Core and SpiderMonkey are also very cool, but less prevalent, especially in the server-side space. But Bon is slowly changing that. So most JS engines probably 10, 20 years ago just did interpretation, which is you have your code, you just run it in your program in a loop, which is great because it's really simple. So it's pretty easy, but then also pretty slow. So V8 kind of pioneered just-in-time in Chrome, which is where you compile to machine code first and then execute, which is a lot more complicated, but also much faster. So because just-in-time engines have to compile, most modern JS engines kind of look like this, where you have to have several stages where you have an interpreter, then several just-in-time tiers where each one takes longer to compile, but also each one gets faster and faster at actually running that JavaScript. So yeah, just-in-time is great for performance, especially micro benchmarks, because then it's just basically raw throughput at that point. So you can get about 10 times faster. In the real world, it's kind of arguable. Like this is a study done by the Edge team for the super duper secure mode, where they see about a negligible difference in power, and then slower page loads, but also better startup times and memory usage. Another big con is security. Around half of all JS engines' security bugs are because of just-in-time. Another bad con is overhead, which is kind of less prevalent, but you can see here in a little benchmark, while it's much slower, it also uses about 20% less memory, which doesn't really matter for most use cases, but if you're, say, an embedded device, it kind of makes JITs a no-go depending on how small you are. So you also have ahead of time, which, like the most famous examples is C++ and Rust. You just give that to Clang or Rust C, and then you just get a binary. So why can't we do this with JavaScript? Well, you can. So Porffor is this. I started it in around October 2023, and then I did it full-time since August last year, since I got funding for it. So I will just go straight into a demo. So I have my little terminal here, if I can spell. So say I just write a nice cool script, like hello hackfest. So I want to run that script, I can just use Node or something, great. But say I want a native binary because I want to ship it to a user and they have Node installed. I can do, say, like Dino's compile. So then I just have a little script which works. Or I can use buns, which does the same thing but is JavaScript core to have some representation. And yeah, that works just the same. The only kind of downside here is if you look at the binary sizes, they're slightly big. 100 megabytes is, I guess you can argue it's fine, but it's not ideal. So if I compile it with Porffor, it's 20 kilobytes. Which is very nice, and it works just the same. With this simple example, it works really nicely because it's just a hello world. So you actually benchmark each of them running. Wait a second, because averages are cool. So you can see Dino takes around 50 milliseconds, 75 megs of memory, because it's an entire runtime. And yeah, Porffor takes around 1 meg of memory. Well, even Bun takes around 32 and takes less than a millisecond because it's just as if you wrote it in C or something, which is nice. But say I need to compile to WebAssembly because like my client really cares about their JavaScript not being reverse engineered because who knows. So if I just have the same file, so the kind of industry standard today is Javi, which just bundles QuickJS into the WebAssembly, because until now, there's no real way to not do that. So that builds, which is fine. It's around 1 megabyte, which is much more reasonable than 100, but still not ideal. So if I compile the same with Porffor, it is, 4 kilobytes, which is also nice, especially if you're, say, shipping this to a browser. That's like almost like 300 times less shipped through the network. And it's also much faster, but I won't demo that because WebAssembly is WebAssembly, which is hard to run on the server for now. So yeah, the architecture inside is pretty simple from a surface level view. You just take your JavaScript, make an abstract syntax tree, turn it to WebAssembly. It more kind of looks like this, which is you have built-in APIs like, say, date, string.prototype, everything like that. You can turn that to WebAssembly and then also optionally make that into C code in the native, because you can just write C code, give that to Clang, and you basically get LLVM optimization for free without having to tie into that. Undersimplified, my summary is optimization is important, especially for JavaScript, for better or for worse. So yeah, the main downside is you're reinventing the JS engine, so it currently passes around 59% of test 262, which is the entire JS spec test suite. So that includes everything from, say, adding 2 numbers or all of temporal. So you might think, is this vaporware? Like, I just showed a binary on my machine. It's on GitHub right now, if you want to use it. One surprising thing is it's written entirely in JavaScript and TypeScript, because I mean, honestly, when I was starting it, I thought it was funny. But the nice thing is, like, if you know JavaScript, you can just contribute to a JavaScript engine. You don't need Rust or C++. And yeah, it's around 20,000 lines, which is pretty small. I think V8 is 1 point something million. So, but like, that's very understandable because they have like that kind of required complexity for browsers. But because I'm targeting just like server-side, like non-browser use cases, it's fine if it takes, say, a minute to compile, but because like the user is not waiting for that web page load. And yeah, so the code is kind of nice for the most part. Like, say so the top one is from the array prototype, which looks kind of nasty but obvious, and the second one is from date, which has some nice spec comments. It's for the most part just normal TypeScript. And yeah, please shout any questions or code to run in a REPL. Thanks. Yeah, I have a nice little REPL here. So you can just shout at me to run things and we can see how it breaks. Yeah, so stuff like with, yeah, so have I tried stuff like with, for now I treat with as like a no-op. So like say you have, so I'll just say A is not defined because I essentially ignore it for now. You know, I shouldn't. With an eval especially is not impossible for ahead of time, but very hard. Like I know Hermes, the React Native JS engine, completely doesn't support with. But so say like eval, if you just give it a constant string, it works fine. But then if you say make this so you can't easily see it statically at compile time. So for this, I just have it in a variable. It will say eval is not defined because in theory, you can do eval ahead of time by like shipping a mini JS engine in your output, but for now, I just hope most people don't need eval in 2025. Yeah, so right now I don't support proxy, but it seems very feasible. So like my object implementation is, I guess, ready for it, but just I've had like bigger things to deal with. Yeah, one thing I completely forgot to demo is. Oh yeah, so
Yeah, I should sell this into the mic probably. Yeah, my question was like, how much type information do you take advantage of to avoid like, JS, like when you compile any JS function, it can take whatever as an input, right? So.
Yeah, so one thing I completely forgot to demo is I also support TypeScript under the box because you control the JS engine, so you can. So say I can define this as an I32, and then just like log that as an I32. So the compiler will see this type annotation and optimize just for that. So like say I do foo plus 2, you can't see the actual bytecode, but I will know like this cannot be a string concat because I know this is a number from this type definition. So yeah, in my experience, it can make a big difference, especially in like a really hot path. You can be around, I think like up to 2 times faster in my testing.
Yeah, what happens if you try and add a float to that number?
I think in this case it should. Yeah, it deops nicely.
Okay.
But in some cases it will just, I think the best example of this is, say I have like a byte string as a type, and I do some Unicode thing, which I've not prepared on brand. Yeah, it will just, yeah. So like say you try and add Unicode to a byte string, right now that will just break your string.
Okay. Yeah, I have another question, which is, I guess, just in general, aside from eval, are there any other features that you don't think will ever be possible or that you're worried about being difficult to implement?
Yeah, I guess for the most part it's just eval or say like new function, any like dynamic compiling things.
Given that your compiler is in JavaScript, would it be crazy to ship that for eval?
That is, I've considered that a lot. It's still far away because, for better or for worse, I'm like, oh, I love these new fancy JavaScript proposals. I use them on my compiler, then I have to support that if I want to compile myself. So it's like a goal, but at least for now, I hope I don't need to have it. But it's like if someone needs eval for a use case, which like they cannot use it, then I would definitely try and invest into that.
How do you deal with memory management? I assume you don't have to ship a GC all the time, like in the binary, but.
Yeah, so I guess right now my memory management is very simple. It's like my allocator is like I wrote it in a day. So it's definitely like I definitely leak memory in places. But I guess for now, for what I'm targeting, isn't really long running use cases. Like say you have like a AWS Lambda thing where it's like, I want this JS function to run on a web server to make a response in like 500 milliseconds. For that, you basically don't need a GC. You can just leak memory until you die. So yeah, it's definitely a problem long term, but at least for now, I've been limited by other things than like having a good allocator in GC.
Are the binary size savings compared to other runtimes that significant also when you have like realistic apps? Because like assume for just console log, there is almost no stdlib you need to ship.
So say I have like an absolute worst case here, which is like I console.log global this. So like I have to include all of the built-ins, even this. Will fail to compile. Yeah. I should not have been doing commits last night. But in my experience, this still gets like at most 1 megabyte compared to like 100 of bundle nodes. So it definitely gets like worse as you include more, but it still limits itself nicely in my experience.
Do you have like a list of, if you were the benevolent author of ECMAScript, is there anything that you would just remove that was too complex that like broke you?
Good question. I guess I can't think of anything too complex. I guess it's mostly the weird things which aren't specified for no reason. Like I guess like a big one is like say date.parse. That doesn't specify which date formats you have to support. So I kind of just used like the 3 most common ones and gave up because at least for now, I'm not too focused on like node compatibility. Just like, can it run JavaScript to the spec? But even some random things like, say, like array.sort isn't specified what algorithm to use. So you just kind of have to look at what JS engines use already to be like, that's probably good for performance and like spec compliance.
Yes, thanks, Oliver, for the presentation. So for Javi, there is a separation between runtime and the actual bytecode of the JavaScript. So you can like split into, for example, Wasm modules. Is it possible with your engine to split all built-ins in a separate Wasm module?
Yeah,
And-
sorry.
Yeah, go ahead.
It's not possible right now, but it's definitely feasible because, like, say, like I have a script here, which I just use some like random prototype just to kind of include it in the binary. So if I run this, it just logs that, but then if I run it with logging all the WebAssembly functions, some nasty things. But say like all these functions could just be split into another file easily because there's like a I guess standard like calling convention I use. So there's nothing where I like break built-ins between files to optimize that heavily. So it's definitely possible. Just I've been limited by the things for now.
Yeah, thanks.
All right, I guess it's my chance to ask you a question. I know that you're using C as a cross-platform IR, but what are your challenges like in terms of using it instead of, say, emitting LVM IR or something more appropriate?
Yeah, I guess the hardest thing is making C which compilers can understand rather than people. Like, if I compile like that hello world, for example, to C, it looks awful. Yeah, it's
Fun.
awful because this is like WebAssembly transferred to C. But in my experience, compilers can deal with this pretty well, even if it looks terrible. Like there's loads of temporary variables, but usually LLVM just optimizes them all out.
Right.
So,
This,
yeah.
at this point, is it useful for you to emit C?
Yeah, I think it's more useful than, especially because like one example is say Zig. From the start, they relied on LLVM, which is great for optimization, but like the debug mode, they're writing their entire own x86 backend now, just to avoid LLVM because otherwise it takes like minutes to compile even in debug. So like possibly I'll add like another backend using LLVM, but for now I'm happy to just have it so I can tell the compiler how to compile it and not rely on one like single backend.
Right. Another question was that one thing you emphasized a lot on was the binary sizes, which was really impressive because you're not embedding an entire JavaScript engine. But how much do you think people actually value that in their day-to-day?
Yeah, I think it's definitely arguable. I think the main thing is, like, say you're an embedded device, that obviously matters a lot, because if you have, say, like 1 megabyte of storage, you can never ship that. You have to use, because like specialty engines for embedded already exist, but the spec compliance can be hit or miss, and the performance is like an interpreter, which is fine for most things, but if you have like a really performance limited use case, it can follow you a lot. So yeah, I think binary size matters, but I guess not a lot. But say it's like, oh, my app is 100 megabytes because I'm shipping Node and I update it once a week. That's like 400 megabytes a month per user. Someone has to pay for that bandwidth.
Yeah.
And if that was 1 instead of 100, that'd be much nicer.
Thanks. Any more questions?
Yeah.
Nico?
Do you have an estimate of how much of, say, ES5 that you pass?
Yeah, so the question was, test 262 involves every single thing in the spec. So how much of ES5 do I pass? I think in terms of like what I have, say, in built-ins is most of it. I think the main thing I'm thinking of is like, say, with or eval. Of course, I don't support. I'm in the middle of rewriting my regex engine. So regex support is very hit or miss right now, but hopefully should be much better. So I guess it's some like edge case things like that. But for the most part, most code, it's gone to the point of like most code will compile, but then there's a bug somewhere and it will crash. So it's more of a test of like endurance now rather than spec compliance.
So you mentioned that you've got 59% passing in test 262. How did you go about deciding what to implement? Is this kind of based on what's actually used and some of the lesser used stuff you've not implemented, or is it more just following the spec through?
Yeah, from the start it was definitely just following the spec of like a list of built-ins and just being like, going through the list. Now it's mostly more of running things, seeing what breaks, and then trying to fix that. That's why there's, I guess like from the first glance there's a plateau there, but it's mostly just fixing things which aren't immediate in test 262. Like say regex things, like will probably be flat until I actually finish it, and then it'll be a huge spike. Because like just parsing regex won't get you any spec compliance because you're not actually running it. Or say, like a big one is say optimization, which you can't see in that graph, but like one classic V8 benchmark, which is Richard's. So this is just like a massively, essentially it's just loads of gross object prototype stuff, like worst case. So like that's basically the worst case for ahead of time because it's very hard to optimize prototype without breaking things. But right now I'm already faster than, say, QuickJS. Yeah, so around 2 times faster than QuickJS for that, which is nice. Which is like not that important for just a micro benchmark, but say like objects generally are really important to make fast. So yeah, it's mostly just a mix of, I guess like what makes sense, I guess like ignoring the raw test 260 number and just focusing on like improving it generally.
What's your iterators and especially async iterators state?
Bad.
Yeah, I'm
That's
having a
my
hard
summary.
time with those as well.
Yeah, generators especially is very buggy. Like some stuff is fine, like say this. Like this is fine, but then if you do, like say some weird void star things. Actually, I think I support this now. Yeah, like stuff like this will break because generators is, I guess, less used today than it was, but like most things I tried to run don't have generators, so I haven't really focused on it. It's definitely possible, just not nice to do nicely, especially WebAssembly has no way to like do the control flow of generators, which is just pause this function. So yeah, it's definitely possible, just annoying.
Is that on? Yeah, Oliver. Did you mention yet where, is there one single big place that's a big chunk of the tests that you still need to get passing for 262?
Yeah, I actually have a script which I can just show live, which is looks at like the most common directories I fail, and unsurprisingly, it's temporal.
Yeah.
Around 8%.
Yeah.
Yeah, then there's some stuff like regex and like Annex B things, and yeah, other internationalization things, which I just haven't gotten around to.
Do you got a plan for focusing on that or at
Yeah.
some particular point?
I mean, the dream for temporal is because it's all written in JavaScript and TypeScript, is I can just take a polyfill, like edit it slightly, and then have temporal support for free, which is much harder than it sounds, but it'd be much nicer than just doing something from scratch.
What's the state of things with other contributors? Do you got some other people that have been contributing?
Yeah, so it was, I guess, no one until recently, but there's a few people now doing PRs, which is really nice, especially because like some commits are like as obvious as they seem. Like, I think there was one recently where it was like a bug in the array prototype, which is just like one line was in the wrong place. Or like it was throwing earlier than it should have, and you just swap the lines around.
Cool.
Thanks.
Okay, I will ask the one question I just got curious about. As someone who started this project, what is your vision for this project? Like maybe, typical question next 5 years or 10 years?
Yeah, I mean, I guess to start it is, I just wanted a new side project, which I would never finish. And like, I knew this is, I mean, people didn't really call it impossible, but I knew it was like infeasible to do well. So I was like, I have free time, I might as well waste on something interesting. So since I like basically spiraled out of control, because I got funding last year, which was completely unexpected, and I was just like, sure, I'll work on this full time, because it's like, I don't know, the most interesting problem I find in JS, at least, myself.
Are you considering using the WebAssembly GC spec for your garbage collector, or are you shying away from it because of the difficulties with using that for the C output?
Yeah, I've looked at it not in full, but it's very interesting. I guess my kind of dream would be you have free modes, which is like no GC if it's super short running, or Wasm GC, or my own GC. So say that you're shipping to embedded, you can use my own GC because they will never support Wasm GC. But then if you're shipping to, say, a web browser, you can have that Wasm GC support, which would be really nice. So yeah, I guess it's just finding a nice way to abstract that. So you can just use any GC. So yeah, Wasm GC is definitely very nice. I like how every browser supports it now, so thank you, browser people.
Yeah, that one was also kind of my question, but I'll state it in a slightly different way, which is, you're taking a garbage collected language and trying to represent it in C, and like there's definitely things that like some things will be easy, and then there's something that will be extremely difficult in trying to do this type of transformation, right? So, like, how do you deal with things like long-lived objects, like things like linked lists and hash maps, and a lot of these things where like, garbage collected languages are easy, and then like if you try to put it in C, it's just going to completely break. Like how do I know for sure that the Wasm file that I get out the other side is like, well-defined and is not going to have like, address sanitizer issues and all these types of things?
Yeah, I guess the nice thing is, so I didn't compile to C. I compiled to WebAssembly and then C. So I compile that WebAssembly to C directly rather than just compiling to C and then to WebAssembly. So just compiling to WebAssembly is like a IR, kind of gives you not a guarantee, but much better safety because you're not just compiling to like arbitrary C code. So it's like I guess like well-defined like what type of C it can output, which helps with, say, memory safety. But yeah, there is definitely some like memory allocation issues, which I think will be fine long term, but just a challenge.
All right. Thank you, everyone, for asking questions, and thanks a lot, Oliver, for this amazing presentation and the enlightening answers. And well, it's